This is 12.2 homework. All right, you are creating self-similar fractal trees. You start with the trunk of length 1 unit right here at stage 0. So this is stage 0. Then the trunk splits into 2 branches, each 1/3 of the length of the trunk. So this would be stage 1. And this would be stage 2. Then each of the branches split into 2 new branches, with each branch 1/3 the length of the previous one. All right, so stage 0 is the trunk, and then you got 2 branches, and off those 2 branches, you got 2 branches. Good. Can the length of the new branches at each stage be described with a geometric sequence? Yes, they can. Explain. The sequence of the length of the new branches per stage have a common ratio relating them to the initial value. And this common ratio is R equals 1/3. Since the new branches are 1/3 as long as the branches of the previous stage. The initial value, f of 0, well, that's A in the formula, equals 1. Here the domain is all whole numbers since the first stage is 0. Okay, the domain is going to be all whole numbers. Remember whole numbers, 0, 1, 2, 3, 4, and so on and so on and so on. So the explicit form of the function would be f of n equals a, which is 1, times r, which is 1/3 to the nth power. And n is greater than or equal to 0. Number 2, can the number of new branches at each stage be described with a geometric sequence? Yes. Explain. Well, the common ratio is 2. So R equals 2 because the number of new branches created at each stage is double the number of the branches from the previous stage. And go back and look at that. Here we got the trunk and then 2 branches, and then off of each branch 2 more branches. So the common ratio would be 2. The initial condition f of 0, which is A, is 1, and that's the trunk. Well, or because that's 1 branch at stage 0. And let's see, the recursive form would be f of 0 equals 1, and then f of n equals 2 times f of n minus 1. Okay, and we'll see if that works. Let's see, f of 0 equals 1, and then f of 1 would equal 2 times f of n minus 1, which would be that one there. So that's going to be 1, so that gives you 2. And then f of 2 would be 2 times 2, which is 4. Let's try that. Let's go back and look. So f of 0 is 1, f of 1, stage 1, would be 2. There's your 2 branches. And then stage 2, f of 2 would be 4. 1, 2, 3, 4. So that worked. All right, good. 3. Can the total length of branches at each stage be modeled with a geometric sequence? Explain. Again, the answer is yes. Yes. The total length is a product of the explicit forms of both functions. The number of branches per stage times their individual lengths. So what did we have? F of n equals 1/3 n times 2 to the n. Okay, that's 1 and that's 2. And since these both have the same exponent n, we can 1/3 times 2, and that would give us 2/3 times, or to the nth power. And of course that would be n is greater than or equal to 0. And let's see, so the equation would be f of n equals 2/3 to the n power. N is greater than or equal to 0. And if you wanted to put the a in there, that would be a 1. So this is a geometric sequence. Write the explicit and recursive rules for a geometric sequence given a table of values. All right. So what do we need to know? What do we need to know? Well, there's 2 things we need to know. We need to know what R is. We need to find out. Well, the equation would be f of n equals a times r to the nth power. That's the equation from the lesson. So we need to find out what a is, and we need to find out what r is for each one of these. Now, r is the ratio. And let's see, the ratio of f of 1 divided by f of 0. And that's going to be 0.3 divided by 0.1, which is 3. You can check it with the next one. R equals f of 2 divided by f of 1. And that would be 0.9 divided by 0.3, which again is 3. And it would continue. Okay. What is A? Well, A is the initial value, and that's right here. The table gives it to you. So the explicit form would be f of n equals 0.1 a times r to the nth power. Okay. The recursive form would be f of 0 equals 0.1, and then f of n equals 3 times f of n minus 1. And n is greater than or equal to 1. Not too bad. Let's try 5. So we need to find out what a is. Well, a is going to be 100. So a equals 100. Now we need to find out what r is. R is, well, that's going to be f of 1 divided by f of 0, which is 10 divided by 100, which is 0.1. Try another one just to be sure, and that would be f of 2 over f of 1, which would be 1 over 10, which is 0.1. Now we can just fill in the equation, the explicit rule. The explicit rule, f of n equals a, which is 100, times r, which is 0.1 to the nth power. The recursive rule would be f of 0, that's kind of sloppy there, f of 0 equals 100. F of n equals 0.1 times f of n minus 1. And that's going to be for n is greater than or equal to 1. Well, they get kind of easy, don't they? They're getting easier. Number 6. So what is r? Well, first let's find out. Let's get a. A equals 1,000. Okay. And like I said, the table gave that. What about r? R is going to be f of 2 divided by f of 1, which is going to be 100 divided by 1,000, which again is 0.1. Now, this is a sub 1, where if you look, this was a sub 0, and this was a sub 0. Where did I put it at? I didn't write it down. Okay, so a sub 0. So this is a sub 1. Well, that's going to make the explicit formula a little bit different. Okay, that's going to make the explicit formula just a tad different. So you're going to have f of n equals a, which is 1,000, times r, which is 0.1, and that's going to be n minus 1. We're going to move it to the right one. All right. The recursive formula would be f of 1, which is 1,000, and then f of n would be 0.1 times f of n minus 1. For n is greater than or equal to 2. Notice the difference in those. Number 7. Now we're going to do it with exponents this time. That ought to be fun. Number 7. A sub 1 is 10 to the 50th. That's our initial value right there in the table. R will be f of 2 over f of 1, which is 10 to the 47th over 10 to the 50th power, which is 10 to the negative 3. And we can leave it like that. So the explicit form will be f of n equals 10 to the 50th, which is a, times r, which is 10 to the negative 3, and then n minus 1 power. Recursive f of 1 will be 10 to the 50th power, and then f of n would be 10 to the negative 3. That's r times f n minus 1, for n is greater than or equal to 2. Getting easier? All right, let's look at number 8 here. Given either an explicit or recursive rule for geometric sequence, use a table to generate values and draw the graph of the sequence. All right, so how do we do this? Well, f of 0 equals 1/2 times 4 to the 0 power. Well, that would be 1/2 times 1, which is 1/2. So we're going to put 1/2 here. And so 0 and 1/2 is going to be right there. F of 1 will be 1/2 times 4 to the first power, which is 1/2 times 4, or 2. So 1 is, well, put a 2 there. 1 is 2. All right, looking good so far. F of 2 equals 1/2 times 4 squared. That would be 1/2 times 16, which is 8. 4 squared is 16. Yeah, 1/2. That's going to be 8. So 2 and 8. All right. F to the third, that's going to be 1/2 times 4 to the third. That's going to be 1/2. 4 to the third, 4, 16, 64 times 64. Well, 1/2 times 64 is 32. And then if we do it to the fourth, that would be 128. All right, so that's 32. And we graphed. Good. Number 9. Number 9. How do we solve it for number 9? So we're given this rule here. So we have f of 0 is 2 times, well, f of 0, it says it's 0.5, so we'll put the 1/2. F of 0 is 1/2. That's right there. So f of 1 equals 2 times f of 1 minus 1. That's going to be 2 times f of 0. F of 0 is 1/2. So 2 times 1/2 is 1. So we got a 1 here. So for 1, we got 1. And that's going to be right there. All right. F of 2 equals 2 times f of 2 minus 1, which is 1, right? So 2 times f of 1, which is 1, and that gives you 2. So we're going to have a 2 here. F of 3 equals 2 times f of 3 minus 1, which is 2. So 2 times f of 2, which is 2, and that's going to give you 4. That doesn't look real good. So 3, let's see, 1 was 1, 2 was 2, and then 3 is 4. All right. F of 4 equals 2 times f of 4 minus 1, and that's 2 times f of 3. F of 3 was 4, so 2 times 4, and that gives you 8. All right, looking good so far. Number 10. Number 10. So f of 1. All right, so f of 1 is 8. We'll put that in there. So 1 is 8. Go ahead and mark that. F of 2 equals 1/2 times f of 2 minus 1. F of, well, 2 minus 1 is 1, right? So 1/2 times f of 1, which is 8. So that's going to give us 4. Okay, so 2 is 4. F of 3 is going to be 1/2 times f of 3 minus 1, which is 2, right? And f of 2 is 4, so we're going to have 1/2 times 4, which is 2. So 3 is 2. 3 is 2. All right. F of 4 is 1/2 times f of 4 minus 1, which is 3. So 1/2 times f of 3, which is 2. So 1/2 times 2 is 1. Okay. And if you hadn't figured out the pattern, the next one would be 1/2. So 4 is 1. 5 is 1/2. All right. Not too shabby. Not too shabby. Number 11. Oh, this is going to be fun. F of 1 is 1. All right. So f of 2 equals 2/3 times f of 2 minus 1. So that's going to be 2/3 times f of 1, which in this case was 1. So 2/3 times 1 is 2/3. So this is going to be 2/3 or 0.6 repeating. We'll say 0.6 repeating. 0.66666, and so on. F of 3 is going to be 2/3 times f of 3 minus 1. Well, 3 minus 1 is 2, so and f of 2 is 2/3. So we're going to have 2/3 times 2/3. And let's see, that's going to be 4/9, which that ends up being about 0.4 repeating. Yes, I'm doing this in the calculator. And then f of 4 is going to be 2/3 times f of 4 minus 1. That's 0.4 repeating. Let's see, 2/3. That's going to be 2/3 times 0.4 repeating, which is about 0.296. 0.296 and some change. So let's see, 1 was 1. 1 was 1 right there. 2 was 0.26. And then 3 was 0.4. That's going to be a little bit, but that's 0.3. There you go, right there. All right, and then f of 5 will be 2/3 times f of, well, 5 minus 1 would be f of 4. That's going to be 2/3 times 0.296, which is 0.197 approximately. A little round in there. Okay. Good deal. Number 12. Write both an explicit and recursive rule for the geometric sequence that models the situation. Use the sequence to answer the question asked about the situation. All right. The Alphaville Youth Basketball Committee is planning a single elimination tournament for all games in each round. The winning team advances and the losing team is eliminated. The committee wants the winner to play 4 games. How many teams should the committee invite? Well, let's see. We need to know what A is. And, we're trying to find out what the initial value is, right? That's what we're trying to find out. Okay, so the explicit rule, the explicit, that'll be f of n, and at the very end, you're wanting 1, and then before that, it's got to be 2 teams, right? And then before that, it has to be 4 teams. And then before that, So, let's see here. You got the winner, right? The winner of the tournament. All right. And then that's going to be based off of two teams here and two teams there, right? And that will be based off of two teams and two teams and two teams and two teams. So 1, 2, 3, got to go one more. So that would be based off of 2 and 2 and 2 and 2 and then 2 and 2, 2 and boy, I ran out of space there. Okay, so that's going to be 2 to the nth power, right? Because 2 to the 0 would be 1. 2 to the first power would be 2, which is two teams, right? And then 2, that's working out. Let's see here. Recursive. F of n. Well, let's see. F of 1 would equal 2, and then F of n would equal 2 times F of n minus 1. All right. So F, we want 4. We want the winning team to play 4 games. So that's going to be F of 4 equals 2 to the 4th power, which is 16. And let's see, 2, 4, 6, 8, 10, 12, 14, 16. That worked out. Good deal. I know you're probably thinking, well, it's just easier to do a tree diagram. You're right, but on something that simple. But what if it was more complicated? Oh, looky here. An online video game tournament begins with 1,024 players. 4 players play in each game. In each game, there's only one winner, and only the winner advances to the next round. How many games will the winner play? So there's 1,024 players, right? And 4 players. So let's divide that by 4. And let's see, 1,024, 1,024, divide 4, 256. So A equals 256. A equals 256. R is going to be 1/4 because only one out of the 4 players advances. So our explicit form will be F of n equals 256 times 1/4 to the n minus 1. And then n is greater than or equal to 1. Okay. Recursive. Let's see here. F of 1 equals 256. F of n equals 1/4 times F of n minus 1. And that's going to be for n is greater than or equal to 2. So let's figure it out. We want to get down to the final person. So that would be 1. That would be the overall winner. And we have 256 times 1/4 to the n minus 1, right? So let's divide both sides by 256, and we get 1 over 256 equals 1/4 to the n minus 1. Okay, now let's see here. 1/4. Let's see, 4 times 4 is 16, 64. Let's see here. I think 4 to the 4th power is 256. Okay. All right, so 1 over 4 to the fourth power equals 1/4 n minus 1. Now look, I have a common base of 1/4 on both of these, so I can say 4 equals n minus 1, add 1 to both sides, and n equals 5. So the winner plays 5 games. The winner plays 5 games. All right, good. 14, genealogy. You have 2 biological parents, 4 biological grandparents, and 8 biological great-grandparents. How many direct ancestors do you have if you trace your ancestry back 6 generations? How many direct ancestors do you have if you go back 12 generations? That sounds kind of interesting. So the initial value, A equals 1, okay? Because you got you, and then you got your mom and your dad, right? And then from them you got your mom and your dad, their mom and dad, and mom and dad. There we go. Okay, so R is going to be 2. R equals 2 because off of each branch is 2. So R equals 2. Explicit. The explicit formula, f of n equals 2 to the nth power. Okay, and that's if you say you're saying that this is 0. Okay, if you want, you can, let's see, that's if n is greater than or equal to 0, or you could say this is level 1, and that would change the equation to f of n equals f of n equals, let's see, 2. That would be A. That would be those times 2 to the n minus 1. Okay, n minus 1. So either one, and that would be n is greater than or equal to 1. Either one of those would work. Okay. Recursive. Well, let's just say that f of 1 equals 2. That's your first set. That's mom and dad, right? All right. And then f of n would equal 2 times f of n minus 1. And that would be n is greater than or equal to 2. All right. So that's both your formulas. Now let's see. F of 6, that's going back 6 generations, would be 2 to the 6th power, which is 64. And then f of 12, that would be 2 to the 12th, which is 4,096. Okay. So if you go back 6 generations, going back 6 generations, you have 64 ancestors. And if you go back 12 generations, if you go back 12 generations, you have 4,096 ancestors. All right. B, what if the explicit rule change? How does the explicit rule change if you are considered the first generation? I kind of already did that up there. If you, let me go back here. If you say A sub 1 equals 1 and R equals 2, then F of N equals, what is that? That would be 1 times 2 to the n minus 1, okay, which is 2 to the n minus 1. All right. Fractals. Wacław Sierpinski designed various fractals. He would take a geometric figure, shade it in, and then start removing the shading to create a fractal pattern. The Cir Sierpinski triangle is a fractal based on a triangle. In each iteration, the center of each triangle is removed. All right, these are actually pretty cool. Given that the area of the original triangle is 1 square unit, write a sequence for the area of the nth iteration of the Sierpinski triangle. The first iteration is the original triangle. So what it's saying is A equals 1. Now, how are we going to find out what R is? And if you look, okay, this is 1, and then look. Now you have 1, 2, 3, 4, 1, 2, 3, 4 triangles, right? And one side is thick. So R is going to be 3/4. All right. So the explicit formula would be F of N equals A, that's 1, times R, which is 3/4, to the N minus 1. And then N is greater than or equal to 1. The recursive, and let me, which equals 3/4 N minus 1 divided N is greater than or equal to 1. All right, the recursive would be F of 1 equals 1. And F of N equals 3/4 times F of N minus 1, provided that N is greater than or equal to 2. Not too bad. B, the Sierpinski carpet is a fractal based on a square. In each iteration, the center of each shaded square is removed. Given that the area of the original square is 1 unit, write a sequence for the area of the nth iteration of the Sierpinski carpet. The first iteration is the original square. Okay, so it's saying this is stage 1, stage 2, stage 3, stage 4. All right, so A equals 1. All right. R equals, well, if you look, you got a square here and a square there and a square there, 3, 4, 5, 6, 7. I miscounted there. 1, 2, 3, 4, 5, 6, 7, 8, 9. So that's going to be 8/9. Okay, R is 8/9. Explicit formula would be F of N equals A, which is 1, times R, which is 8/9, to the N minus 1 power, provided N is greater than or equal to 1. You got to define that. All right. Recursive. F of 1 equals 1, and F of N equals 8/9 times F of N minus 1, provided N is greater than or equal to 2. Now it says find the shaded area of the fourth iteration of the Sierpinski triangle carpet. So f of 4 equals 8/9 to the 4 minus 1. 4 minus 1 equals, let's see here, 8 over 9, and then close parentheses, caret, and that's going to be 4 minus 1, and that gives us 512 over 729. 512 over 729. And you know, let's see, control, enter, 0.702. So that's going to be approximately 0.702 square feet. Not a problem. Got that. Got that. A piece of paper is 0.1 millimeters thick. When folded, the paper is twice as thick. Find both the explicit and the recursive rules for this geometric sequence. Oh, this sounds like fun. So we're going to let n equal the domain, the number of folds, starting with 0 folds. So n equals number of folds. All right. And we're going to start with 0. So that means A equals 0 folds, which, not A. So since the domain is whole numbers, it's got to be whole numbers, 1, 2, you can't do half a fold. You might fold something in half, but you can't do half a fold. So we can use f of n. F of n equals a times r to the n power for the explicit rule. So f of 0 equals, well, that's going to be your a, which is 0.1, because we're trying to find out how thick it is, right? All right. And then r equals 2, because each time you fold it, it makes it twice as much. So our explicit rule is going to be f of n equals a, which is 0.1, times r, which is 2 to the nth power. And then our recursive will be f of 1 equals, well, it's not 0 folds. We started at 0 folds. F of 0 equals 0.1. And then f of n would equal 2 times f of n minus 1. N is greater than or equal to 1. All right. Studies have shown that you can fold a piece of paper a maximum of 7 times. A maximum of 7 times. How thick will the paper be if it is folded on top of itself 7 times? So f of 7 equals 0.1 times 2 to the 7th power. All right. Let's do that in our calculator. So we got 0.1 times 2 caret 7. And we get 12.8. That equals 12.8. So the paper would be, the paper would be 12.8 millimeters thick. Not tick, but thick. All right, good. And what about, C? Assume that you could fold the paper as many times as you want. How many folds would be required for the paper to be taller than Mount Everest at 8,850 meters? All right, it gives you a little hint there. Well, first off, we need to convert, let's see, 1 meter equals 1,000 millimeters. And I'll just use the shorthand there. All right, so we have 8,850 times 1,000. So we're going to have 8,850,000. Okay, millimeters. So F of N will be 8,850,000 millimeters. All right. Now, let's see here. We've already figured out the formula, right? We found the formula earlier. F of N equals 0.1 times 2 to the nth power. All right. So we're going to have 8,850,000 equals 0.1 times 2 to the nth power. Now you can divide both sides by 0.1 and you get 88,005. 88,005, yeah, because we're just moving it over 1. 1, 2, 3. Move that over. Divide. 1, 2, 3 equals 2n. There we go. 88,500,000. All right. You know, I'm not that good. So what I'm going to do is I'm going to take this right here and I'm going to put it in calculator. Remember, we had that menu 3, 1 numeric solve. So I'm going to put 8,850,000. Do I got it there? Let's see. 8,850. I think I need one more zero. Equals 0.1 times 2 caret n. All right. Now, comma n, don't forget that. Remember, this is n solve. All right. Numeric solve. And we hit enter. We get 26.399. Okay. Now, n has to be an integer, right? So 2 to the 26 is less than 8 million. 88,500,000, which is less than 2 to the 27th, right? And since n has to be an integer, and we want something that is taller than Mount Everest, it can't be 2 to the 26th. So it will take 27 folds to surpass Mount Everest in height. Cool. So what else do we got? Justify your reasoning. Suppose you have the following table of points of a geometric sequence. The table is incomplete, so you do not know the initial value. Determine whether each of the following can or cannot be the rule for the function in the table. If a function cannot be the rule for the sequence, explain why. Well, let me show you how to do these. F of 4 would equal 2 to the 4th, which is 16. So it can't be A. All right. Look at C. F of n equals f of 0 is 6. But you can work on the rest of those. 18. Lesson performance tests. These are always fun. Have you ever heard of musical octaves? An octave is an interval between a music note and the same music note in the next higher or lower pitch. The frequencies of sound waves of successive octaves of a note form a geometric sequence. For example, the table shows the frequencies in hertz or cycles per second produced by playing the note D in ascending octaves, D sub 0 being the lowest D note audible to the human ear. All right. Explain how to write an explicit rule and an recursive rule for the frequency of D notes in hertz, where n equals 1, D sub 1, n equals 1 represents D sub 1. Okay. All right. Well, if we want to write, we're going to need to know what, it gives us A sub 0. All right. That's A sub 0 equals, that's A sub 0. It gives us our starting point, right? Okay. Now we need to find out what R is. So R equals D sub 1 divided by D sub 0, which is 36.71 divided by 18.35. If you put that in the calculator, it's about 2.001. All right, D sub 1 divided by D sub 2, that's going to be 73.42 divided by 36.71, which is 2. And then R equals D sub 3 divided by D sub 2, which is 146.83 over 73.42. And again, that's about 2, okay, or 2.000000. So we're going to go with R equals 2, okay? And we've got F of 0 equals A, which is 18.35. So our explicit rule would be F of n equals 18.35. That's A times 2 to the nth power for n is greater than or equal to 0. Our recursive rule, that would be F of 0 equals 18.35, and then F of n would be 2 times F of n minus 1, provided n is greater than or equal to 1. Not too bad. B, the note commonly called middle D is D sub 4. Use the explicit rule or the recursive rule from part A to predict the frequency for middle D. So F of 4 equals 18.35 times 2 to the 4th power. Let's see, you put that in your calculator, you're going to get 293.6. So the frequency of middle D is about 293.6 hertz. 293.6 hertz. All right. Humans generally cannot hear sounds with frequencies greater than 20,000 hertz. What is the first D note that humans cannot hear? Okay, so let's set that up. We already know what our equation is, so we got 20,000. So basically f of n equals 20,000. All right, and that's going to be 18.35 times 2 to the nth power. So we're trying to find out what n is. Let's put that in our, let's do n solve. Me and you, 3, 1, and we've got 20,000. 1, 2, 3 equals 18.35 times 2 to the nth power. Where's n? There we go. All right. And we're looking for n, so comma n. You got to put that in or it won't work. Press enter, and you got 10.09. So n is approximately 10.09. Okay, the first D note that humans cannot hear is going to be D sub 11. Okay, D sub 11. And the reason why I'm saying D sub 11, because D sub 10 is, well, it's going to be 18.35 times 2 to the 10th power, which is 18,790, which is less than 20,000. So D sub 11 is the first one that is greater than 20,000. All right, greater than. Great homework, folks. I'll see you tomorrow in class, and y'all enjoy your day. Thank you.